So now I'm going to go over the free response number 3. We did not go over number 4 in class. I'm going to post the answer and send it to you guys. But let's do free response number 3. So hopefully you tried it on your own. And if so let me go over how you find it. Okay, so obviously this is a piecewise function made up of 2 separate pieces, made up of a square root function and an absolute value function. So first we'll deal with the square root function. I'm going to do the constraint first because that's easy to see. It goes from here to here. So it goes from -5 included, so a line underneath, to x to 1 not included, so there's no line under that piece. So now I just have to figure out how my absolute value my square root function has been changed. So if you remember, the parent function normally looks like this. So obviously this has been shifted over and down. It's been shifted over 5, left 5, so it's going to be a +5 inside the square root, and -4, down 4, so that's going to be a -4 after the square root. The only other catch is normally the square root function is up 1 over 1. This one's up 2 over 1. So this one is a vertical stretch. That's a vertical change, a y change. So that's going to go in front of the square root function. So it should be, there's my vertical stretch, absolute value, x +5, that's the shift left, -4, that's the shift down. The absolute value function is a little bit easier because it does not have a stretch or compression on it. The normal absolute value function looks like this. It does have a reflection though. It has been shifted right 3, up 3, and turned over. Flipping it over this way, that's a reflection across x, but that is a vertical change. It's changing from being up to being down. So that's going to go in front. So it's going to be a negative in front, x +3, and then up 3. The constraints here, it goes from 1, the same 1, also no line underneath, to infinity, so actually you would write that as x is greater than 1. If you wrote it to infinity, I wouldn't count that wrong, but that's mixing 2 notations. It's mixing algebraic notation and interval notation. So I think each piece is worth 1. So if you got the square root, you get +1. If you got the absolute value, you get +1. Alright, so next, this one's a little tricky the way it's worded. They give me f of x is all of this. For what value of a does f of 3 equal all of this? Well, first let's figure out what this is. So -2 times g of -4, so I'm going to go to g of -4, and that gives me -2. -3 times g of 3, which is 3. So it's positive 4, -9. So I get -5. So all of this equals -5, and that's worth a point if you get that. So what they're asking me is for f of 3 to equal -5. So here's f. I'm plugging 3 in. So that's going to be, all my x's become 3's. But I still have a variable. I have that a. So I'm going to set this equal to 5 and solve for a. So we get a equals 1/3. Is that right? Is that right? That's worth a point. I think pulling the values off the graph is worth a point too. So this one's worth 3 points altogether. This, a is 1/3, and the numbers off the graph. So that's +3. Alright, then on C, g of x is less than 0. Explain what this means about the graph. Well, if it's less than 0, then g of x is below the x-axis. And it asks us to state the interval where that's true. g of x is below the x-axis from here to here, so from -5, bracket, sorry, it's a solid dot, -5 to -1, parentheses, because there's no equal sign under here, so it's just where it's below. In union with, it goes back below right here and on to infinity, so 6 to infinity. And then lastly, explain graphically what it means if g of x is greater than or equal to. That means g of x is on or above the x-axis. They ask us to state the interval where that happens. Well, it starts here. You have to stop because of this open circle, because the graph stops there. So you're going to go -1 to 1 in union with 1 to 6. Both of the -1 and the 6 get brackets because if you look, they equal 0 right here, and it said it could equal 0. Okay, I'm sorry, I didn't even tell you point values. This is worth 2, and this is worth 2. The statement is worth one thing, and the interval notation is worth 1 on both of these. So again, it's worth 9.